is problem number 7 on page 74 in the textbook. The problem reads, the average length of a 6-year-old striped bass is 27 inches. I'm going to write down the important information. 6 years old, 27 inches. And a 20-year-old striped bass is 54.5 inches. A striped bass's age and the average length are approximately linearly related. That tells us that we can find a slope, and we can put this into the equation y equals mx plus b. The question says, let L be the average length in inches of a striped bass at age years old. Find an equation of a linear model to describe the information. So we're looking for a linear model. We know we need to find y equals mx plus b. We also know that the age is our independent variable. The length is our dependent variable, because as a striped bass gets older, it's going to grow, just as a person. So we can have our point 1 as 6 years old, 27 inches. So that's one ordered pair. The 20-year-old striped bass is 54.5 inches. So we can use this information to find the slope. Our slope formula is y2 minus y1 over x2 minus x1. Plug this information in. I'm going to say 54.5, that's my y2, minus 27 y1, divided by x2, 20 minus 6. You get the calculator out. $54.5 minus 27 equals 27.5, and 20 minus 6 is 14. So our slope is equal to 27.5 over 14, and I'm okay if you leave it as a fraction. So now we need to find our y-intercept. We've already found our slope. We're given two x and y points, so I'm just going to pick one of these. I'm going to pick the point 54.5, this is my y, is equal to the slope 27.5 over 14 times the x 20 plus b. Right? So this is our x and our y. They came directly from this ordered pair. I'm going to put that into the calculator. So 27.5 divided by 14 times our input of 20. We have the equation 54.5, that's our y value, is equal to 39.29. I just rounded up because the next number in the thousands place is above 5. Finish the equation. Plus b. Our last step is to solve for b. Subtract 39.29 from both sides. 54.5 minus 39.29. We find that b is equal to 15.21. We had to find the equation of the linear model. So we have y equals mx plus b. Remember, we're only substituting in what we calculate here. So we have y is equal to the slope, which we found up here, 27.5 over 14x. times x plus our y-intercept, which we found to be 15.21. And we found the linear model for the relationship between the age of a striped bass and its length. Again, this was page 74, number 7. Next, we're going to look at page 75, number 15. So they give us a table of the percentage of Americans who are basketball fans. So I'm going to recopy the table here. So we have years and percent. So the year was 1999. 54% of the people were basketball fans. In 2001, 51% were basketball fans. 2003, 50% were basketball fans. 2005, 48%. 2007, 44%. And 2008, 43%. Continuing the question, let P equal the percentage of, so P is the percentage of people who liked basketball T years since 1990. So this since 1990 is important because when we want to take the data they gave us in the chart and make our ordered pairs. Right? So I'm just going to make another column here. I'm going to erase my T years since 1990. Oops. Just so I can fit everything in so you can see it. So I'm going to make this as my ordered pair, x comma y. You could say t comma p, where t years since 1990. So in 1999, we were 9 years away from 1990. So our ordered pair is 954. And I can continue here. So to get these values, the 18, 17, 15, 13, 11, all I did was take, for 18, 2008 minus 1990, it was 8 years ago. Right? So we have our ordered pairs. Use a graphing calculator to draw a scattergram of the data. All right. So here's a graphing calculator. Let me put it over here someplace so you don't see the shadow. But I want to be able to see the data. All right. So to create the scattergram, the first thing we're going to do is we're going to hit the second stat plot button. So second stat plot. And what I want to make sure is it says plot 1 is on. So I hit enter with plot 1. I see that it's on. And I also want to make sure that the type, where the lines are not connected, is also on. So your calculator may look a little bit different. That's okay. Then we're going to go hit this stat button, which is right underneath the delete. So I hit stat. You want to hit edit because we're going to edit our plots. So right now you see that I have some numbers in here that were left over. I'm going to use my arrow key to highlight where it says L2. I'm going to hit clear and then I'm going to hit enter. I'm going to arrow over so that line 1 at the top is highlighted. I'm going to hit clear and I'm going to hit enter. Now I'm just going to go down my table of values and enter the information. So I do all my X's and then my Y's just so I don't have to go both, go back and forth. So I just enter all of my X's, use the arrow to get over to line 2, and I'll enter all of the Y's. I missed one. 54, 51, 50, 48, 44. Nope, I was good. Great. So now if I hit graph, I don't really see anything. And the reason we don't see anything is just how I have my window set. So what we want to do is we want to check the domain and the range. So remember, the domain is the set of all your input values. So we're going to hit this window button, and we're going to adjust the display window. So my domain goes from x is 9 to x is 18. And I want to give myself some wiggle room so I get a better picture of the graph. So I'm going to say that my x minimum is 5, meaning that's going to be the smallest place it shows on the value. And my largest, I'm going to say, is 20, right? Because the largest x value is 18. So again, I want some wiggle room. I'm going to say that the space between them is only 1, because these are going up by 1 or 2 points each time. And the y-min, we want to check our range. The smallest number that we have in our range is 43. So again, to give the wiggle room, I'll set the y-min at 40. The max is 54. So for some wiggle room, I'll set my y-max, oops, on at 40. My y-max, I'm going to say, is 60. And again, I'm going to put this as a scale of 1. And then I'm going to hit graph again, and what we see is we found our scattergram. We can see that these lines do have a general decreasing trend, which makes sense because as our x values are increasing, our y values are decreasing. So they don't all form on a line, but we can say that they are approximately linear related. The next part of the question asks us to find an equation of a line to model the data. So to find a line to model the data, we're going to use our calculator instead of having to draw the scattergram and graph it. And so to do that, I'm going to go back and hit the stat button again. Instead of having edit highlighted, we want calc highlighted. And we want to scroll down to this, the linear regression, or linreg, ax plus b. So notice it's kind of in the form mx plus b. So you can either scroll down or hit 4. My calculator requires me to hit enter through all of these. Yours may not. And hit enter and calculate. And what it does is it gives us an equation that they say is in the form y equals ax plus b, which is very similar to our linear model, mx plus b. And we substitute a in. So we say that y is equal to negative 1.19x plus 64.86. And that is a model for the data that was given to us in the table.